polygons. Okay. While I'm passing these out, don't write on these yet, guys. What's a three-sided shape called? Okay. What's any four-sided shape? Quadrilateral. Five sides? Six sides? Seven sides? Hexagon. How about eight sides? How about nine sides?
Nonagon.
Nonagon. And then 10 sides? Decagon. Okay. If there were any of those you didn't know, I would say maybe write down. Again, don't write on these yet. That's the next thing. If there's any of those that you didn't know, maybe write those down. Especially if you know that you tend to mix up like hexagon and octagon. That's pretty common. So again, I would say write those down. Because you might get problems like, hey, here's a hexagon, and you have to know how many sides it has, and I'm not going to tell you. So if you know you tend to mix stuff up, here we go. This is up for you. We're going to get there. It's not that hard. I'm sorry. While you're writing your official definition for a polygon, it's a shape enclosed by straight lines. Is a circle a polygon?
Yes. The shape in. Oh wait, it's not straight lines.
It's not a straight line, so it's a circle polygon. No. So if it has any curved sides, it is not a polygon. So like circle's not, half circle's not. So, okay. Are we good on this? No. Okay. Alright, we're going to use your table next. So we're talking about polygons and angles. So the first thing we're going to talk about is the sum of the interior angles on any polygon. So that's the table I just gave you guys. Are you okay now? Okay. So you guys have this. This row right here won't make sense for the formula for the sum of the interior angles. You guys just created the formula. That's what it actually is. And this is why. Like we went through this table, like this is why the actual formula for the sum of the interior angles is n minus 2 times 180. That's how I feel. I can actually show you that. Isn't that basically what we just wrote?
Yeah.
That is your actual formula for the number of sides. Or for the, for the sum of the interior angles in any polygon. Okay? So now we can use that. We didn't do that. Remember I said you'll need to know these? Nonagon has how many? 9. 9. Cool. Plug into your formula. 9 minus 2 is? 7 times 180.
1,360.
160? Yes, 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 maybe guys?
That was fast. 1,260.
1,260? It's plug in and use the formula. Okay? That's how you're going to have to use this. Or I can give you stuff like this.
Oh.
How many sides does it have?
5.
Okay, so we can either use the formula, or in this case, you can look on your table. Since we did 5, add up please, you're going to be doing stuff. Solve stuff. Okay?
Well, we use a calculator.
You did it?
No, I didn't.
Oh, yeah.
You guys are all cheating. Tim.
Okay.
Yeah, could you fish?
I heard from several of you, what do you got?
113.
113, okay. We know the sum is 540. We can either use our formula or we can look at your table because we already did that one. And then we can, add those up and subtract and get 113.
How did you subtract it?
Does that make sense?
Yeah.
Okay, good. Okay, so these were all I was talking about, just any polygon. But now what if I said a regular polygon? What makes that different? Because when I say regular polygon, that actually has meaning in math.
Oh, what is all this? Angles are the same one.
Angles are all the same, and one more.
The length is the same.
You guys hear that? Kind of important. Kind of important, guys. Yes, I'm gonna write that down. Your regular polygons are the ones that are like nice, pretty, perfect shapes. They're the ones you can usually recognize because you're like, oh yeah, that's the ones you usually see. They're not the awkward, lopsided ones that I draw, obviously. That's not so good. Can I go on and show you something?
See.
Yes.
Okay, that's the other side. All the angles are the same, both sides are the same. You want to shorten that? That's all it is. Okay? Okay, which ones of those are regular? All the angles are the same.
I don't even know.
The square. Three of them.
Four.
Four. There's three. Oh, with the hexagon also.
Is that one regular?
Yeah.
Here's that one, if you're square.
Yeah.
Square octagon.
Yeah.
Is that one regular?
No.
Why?
One over there, but okay.
Yeah, those two are shorter than those two. And the rest of these, my angles aren't the same, or the sides aren't the same. So those are my three that are regular, okay? Here's how we can use that now. So those are my three that are regular. We know how to find the sum, but if I want one angle, if they're all the same, I would just divide how many angles there are, and I would find what one is. Does that make sense?
Yeah.
Okay, so look on your table, we did octagon, right? What was the sum of all the angles for an octagon? 1080. What if I only want one of them? How many angles are there? 8, which gives me 135. So it means that angle's 135, and that one's 135, and that one's 135, and so on all the way around. I'll put it right there. Okay. Now this one you know. They're all 90s, right? We know that one, but it still works. What's the sum of all the angles?
360.
360. What's 360 divided by 4?
90.
90. They're all 90. What's the hexagon?
It's 540.
It's 540. Okay, so 540 divided by 5 gives us 108. So each angle in there is 108, and so on all the way around. Does that make sense to everybody? That's how we can use that stuff. Okay. So that's interior angles. Interior angles now. Okay.
What did you just take that angle and
Divide it by.
subtract it from 1?
Okay, now, that's one way to do it. Everybody back there, pay attention, please. That's one way to do it. They're saying, couldn't we take this angle and subtract from
180.
180 and it would give us that one, right? Because we know those two together are going to make 180. Okay? That's one way to do it. But we're going to talk about what's the sum of all the exterior angles. sum of all the interior angles, we have a formula for that. The sum of the exterior angles is actually even nicer, even easier. And I'm going to show you. I'm going to show you. Okay, so
I like
watch this. I have it animated. I did not make it, but I'll take credit for it. He's going to give me credit for it. So see as he's going around,
Yes.
he's making exterior angles as he goes around.
Yeah.
So, yes, I know mathematically you could figure out what one of the interior angles is and find one exterior angle and then add them all up. But think about it this way. He went all the way around the shape. There's your hint. Around. What's the sum of all the angles then?
360.
360. So if I did my mathematically way, I'd have 72. What's 72 times 5? 360.
360.
Okay, guess what? That's always true. The sum of the exterior angles is always 360. Yes, please write that down. How? Remember, didn't he go around the shape?
C.
He's going in a circle. It's in a circle. So you're making a circle around your shape, and we know circles make 360. So that is always true for our regular polygons. Yes, please write that down.
With pleasure.